So welcome to our first class. Our topic for discussion this morning is trigonometry. I'm sure all of you would have heard that word before. Am I correct?
Yes, Miss.
Good. So what we're going to be doing today, by the end of the lessons, everybody should know how to identify the different parts of a right angle triangle. You're going to be able to determine the different ratios for general angles, and then we're going to finally use these different trig ratios to find unknown angles. So I'm going to ask for a volunteer to look at the screen and read what it says there is trigonometry. Could we use Tristan? Can you kindly tell us what trigonometry is? Tamika, do you want to read what it says is trigonometry? Please unmute. Thank you.
Trigonometry comes from the Greek word trigonon, meaning triangle, and
metrikos,
meaning measure. Trigonometry is a branch of mathematics concerned with measurements of triangles. It is used to surveying, navigation, electronic business, and astronomy.
Thank you very much, Tamika. So it's a very big word there, trigonometry. It's a big word, but it simply has to do with triangles, as the first three letters indicate. It has to do with triangles and measuring of these angles, okay? So don't worry with the whole big term trigonometry. It has a very small meaning. Now we're gonna examine three basic trigonometric ratios. Can somebody tell me what are these three ratios? Can I have a volunteer to tell me the three ratios that we're going to be looking at? They're mentioned right here on the screen. All right, so we'll be looking at the sine, cosine, and tangent ratio. Sine, cosine, and tangent ratio. These are the three ratios that we'll be looking at. But before we examine these ratios, we first need to look at the parts of a right angle triangle. Now, can someone please identify the different parts of the right angle triangle for me? Go ahead.
The opposite side, the hypotenuse, and the adjacent side.
Very good. Thank you very much. So the hypotenuse, as the diagram shows, the hypotenuse is always the longest side. So the longest side, it doesn't matter the direction of the triangle. When you look at the triangle, the hypotenuse, it's always the longest side of the triangle. The opposite side is the side that is directly opposite of the angle. Now, there's an angle here at A. Everybody seeing A on the screen?
Yes, Miss.
Good. There should be an angle there at A. There should be an angle at A, and the opposite side, it's always directly opposite to the angle. We're not talking about the 90-degree angle, but we're talking about there's an angle at A. There should also be an angle at B, but our focus is on the angle at A. Now, there should be an angle there. And so the opposite side, it's directly opposite to that angle. The adjacent side, however, is next to the angle. Is everyone seeing the adjacent side?
Yes, Miss.
Yes, Miss.
Thank you. It's next to the angle, but the opposite side, it's always directly opposite to the angle. Are you clear so far? Any questions? Well, since there's no question, we can move on. So as I mentioned before, we're examining the three trigonometrical ratios: sine, cosine, and tangent ratio. Now, the sine ratio, the formula for the sine ratio is the sine of an angle is equal to the opposite side over the hypotenuse. The opposite side over the hypotenuse. Now, if you look at the first triangle there, we have the angle to the bottom there, the angle being colored in purple. Now, the opposite side is the one that is directly opposite to the angle. And as we mentioned before, the hypotenuse being the longest side. So the sine ratio uses the opposite side and the hypotenuse. Is everyone seeing that?
Yes,
Yes, miss.
Very good. So the sine ratio always uses the opposite side and the hypotenuse. Now, if you look to the triangle right to the bottom of that first triangle, you'll notice in this case, the angle is at another point. Are you seeing that? We're not looking at the angle at the bottom. We're looking at the angle at the top of the triangle. But however, if we're to use the sine ratio, we're going to be using the opposite side, which is directly opposite to the angle. And again, we're using the hypotenuse. So make a note of it. The sine ratio is equal to opposite over hypotenuse. Opposite over hypotenuse. Now, what about the next ratio? We're talking about cosine ratio. The cosine ratio takes into consideration the adjacent side and the hypotenuse. The adjacent side and the hypotenuse. So the cosine of an angle is equal to the adjacent side over the hypotenuse. Everybody seeing that? Okay. Everyone is clear so far. Any questions? Okay. Now we'll look at the final.
Go over it one more time.
Okay. We will surely do that. Let's look at the tangent and then we'll come back to all three. All right. Now the tangent of an angle is equal to the opposite side over the adjacent side. The opposite side over the adjacent side. Now looking at the triangle there, under tangent ratio, we see the angle to the bottom there that is colored in purple. Now, it takes into consideration the opposite side, which is the side directly opposite to the angle, and the adjacent side, that's the one to the bottom of the angle. So the tangent of an angle is equal to the opposite side over the adjacent side. Can someone tell me which type of triangle you notice we're using in all three cases? Anyone? Can you look at the triangle and tell me what?
Right.
Go ahead.
Miss, a right angle triangle.
Very good. So these ratios that we're using, they are in relation to right angle triangle. They can be used only for right angle triangle. So let's go it over one more time. This time, you'll help me. So I'm going to use gyro to tell us about the first ratio, which is the sine ratio. So when we're dealing with the sine ratio, what two sides must be included?
The opposite and the hypotenuse.
Very good. So if in any question you're given the opposite side and you're given the hypotenuse, you should be using the sine ratio. It takes into consideration the opposite and the hypotenuse. Now we can go on to the cosine ratio. The cosine ratio uses which two sides?
The hypotenuse and the adjacent.
Yes, the adjacent and the hypotenuse. So if you're given the adjacent side, you're given the hypotenuse, it becomes obvious that you should be using the cosine ratio. Now the tangent ratio, if you're given the opposite side and you're given the adjacent side, you should be using the tangent ratio. Now, it's easy to remember because some people say it's SOHCAHTOA. Have you ever heard that before? SOHCAHTOA? Or there's a little saying, in order to remember the three different ratios, some people say some old hearses can always hear their owner approaching. And in that way, you remember the different sides of the triangle that you need to use for the different ratios. So let's try to say it together. Some old horses can always hear their owner approaching. So by saying some old horses, you're remembering the sine ratio, which says sine is equal to the opposite over the hypotenuse. When you can always hear, you're actually saying cosine of an angle is equal to adjacent over hypotenuse. Then when you say their owner approaching, you're actually saying the tangent of an angle is equal to the opposite side over the adjacent side. Please feel free to come up with your own little rhymes so that you could remember the different ratios. But just remember that these ratios are used in connection, or as a matter of fact, they're only used in connection with right angled triangles. We have an example here. So let's look at the triangle that we're given here. Now, the angle is to the bottom there. Do you see a little something looking like a circle there? It's a symbol. We call it theta, or some people say theta. It's a symbol used for the unknown angle. There's an angle here to the bottom there where you see that little circle. Is everyone seeing it?
Yes.
Good. So we're given two sides of the triangle. We're given two sides of the triangle. Can someone tell me what are the two sides that we're given?
Miss, the two sides that are given are the opposite and the hypotenuse.
The opposite and the hypotenuse. Thank you very much. And what's the length of the opposite side?
10 cm.
And the hypotenuse?
20 cm.
Very good. Very good. So you just look at where the angle is, and then you will know which sides you're being given. The angle is to the bottom there. The opposite side is directly opposite to the angle. And of course, the hypotenuse being the longest side. So we're given the opposite side, we're given the hypotenuse. Can someone tell me which ratio caters for the use of the opposite side and the hypotenuse?
Miss Sine.
Sine. Very good. So if you focus on the screen here for me for 1 minute, it says sine of the unknown angle, which is to the bottom there, the little circle, we call it theta or theta. Some people say theta. I like to say theta, but you can feel free to say theta. So the sine of that angle that we do not know is equal to the opposite side over the hypotenuse. Or you could just simply remember your little rhyme. Some old horses, meaning sine is equal to opposite over hypotenuse. So sine theta would definitely be equal to the opposite side, which is 10, over the hypotenuse, which is 20. But a point to note is that we're trying to find the size of an angle. We want to know what is the size of that angle to the bottom of that triangle there. In order to find the size of an angle, if you have your scientific calculator nearby, how many of you have your scientific calculator? Now, with your scientific calculator, all you need to do is to press second F on your calculator, and then you press sine. It's right there on your calculator, second F, and then you press sine. Now, after you would have pressed that, you will get sine inverse. Sine inverse you'll get. Sine with this -1 to the top there. Sine inverse, and then in bracket, what you can put is 10 over 20. Then you close bracket. And that should give you 30 degrees. Did anyone try it so far? Anyone? Do you need me to go it over one more time? Is everyone seeing clearly?
Yes, Miss.
Please feel free to ask your questions, okay? Questions are necessary if we are going to learn. So ask your questions. And I always tell my students that there's no foolish question. The only foolish question is the one that we fail to ask. So let's go it over one more time. So we're looking at our triangle here again. And as I indicated before, the angle is right to the bottom there. So the little circle with what I'd say is a scratch to the top of it, that means that's where the angle is. That's theta, the unknown angle. Now, what are the sides that we're given there? Anyone, please unmute and tell us your response. What are the two sides of the triangle that we're given?
The opposite side and the hypotenuse.
Thank you. Now, which one of the ratios cover or consider the opposite side and the hypotenuse?
The sine.
Very good. The sine ratio. So what we're actually trying to do, kids, we're trying to find the size of that angle that is at the bottom here. We want to know how much does this angle measure. Hence, we're using the sine ratio because we're given the opposite side and we're given the hypotenuse. So let's try it here. We say sine of that unknown angle, or sine theta, is equal to the opposite side, which is 10 cm, over the hypotenuse, which is 20 cm. How many persons have their scientific calculator close by? Because since we're doing trigonometric ratios, you would need a scientific calculator. Please unmute and indicate whether you have your scientific calculator available.
I have one, Miss.
Good. Anyone else?
Yes, I have
It's not
mine.
at the moment.
All right. So going forward, students, we need our scientific calculator. We cannot do trigonometry without a scientific calculator. So if you don't have one, kindly borrow one, or you can purchase one if it's possible, just so that you have it. Because for our class tomorrow, we're doing trigonometry too. As a matter of fact, for the next month or so, we're going to be focused on trigonometry. So please get a scientific calculator. So as I was saying, the sine of an angle is equal to the opposite side over the hypotenuse. So sine theta here would be equal to the opposite side, which is 10, over the hypotenuse, which we know is 20. Are you with me so far?
Yes, Miss.
Okay, thank you. So in order for us to find the angle, we need to sine inverse 10 over 20. In order to find that angle that we don't know, we have to sine inverse 10 over 20. So in order to get sine inverse, we press second F on our calculator, second F on the calculator, and sine. Second F and sine. Once you press second F and sine on your scientific calculator, it's going to give you sine inverse, or sine with a -1 to the top. Now, sine inverse, after you would have gotten that, you can put in the rest of details. 10 over 20. And for those of you that know to use the fraction function on your calculator, it's easy. You simply press 10. There's a function saying AB over C, or X over Y on some calculators. So if you press that function, you get a little R, and to the bottom, you put the 20. So sine inverse 10 over 20 will give you 30 degrees. So this little angle here, theta, we now know that it's valued 30 degrees. Any questions so far? Okay, well, here you have a chance to participate in our lesson. You are given a chance to participate. Kindly look at the second number 2 there. That's going horizontally, going across. Number 2, kindly look at it. And you will tell me which ratio we're going to use for number 2. So take a good look at it. Number 2, that's going across, not down, across. So we just did the first one. So kindly look at the second one and you can tell me which ratio we'll be using in connection with that unknown angle. I'll give you 2 minutes.
Miss, we'll be using the cosine ratio for the second one.
Very good. And why is it that we're going to be using the cosine ratio? I need another volunteer to tell me why we'll be using the cosine ratio there. What 2 sides are we given?
The hypotenuse and the adjacent.
Very good, very good. We're given the adjacent side and the hypotenuse. Thank you. So I need another volunteer to go ahead and find the cosine of that angle there and tell me the value. So everyone can work on that. Are you ready? Please indicate, students, that to the top of your calculator, you're seeing DEG, which means degrees, and not RAD or GRAD. Please indicate that to the top of your calculators, you're seeing DEG, which means degrees, because we're trying to find the angles in degrees. So that's just one point that you must know. Are you ready?
4 minutes remaining, miss.
Okay. So we need to get our answers in that 4 minutes. Anyone?
Excuse me, miss, how you set your calculator to DEG?
Look to the right-hand side of the calculator. There's a function there. It marks DRG. Do you see it?
No, miss. I got a Casio calculator.
You have a Casio, but just search the calculator and see if you're seeing a function marked DRG or DEG. So you can take a picture of the information that is here because you'll be working the remainder of the sums. So you can take a screenshot. Those of you, you can take a screenshot or I can send it to you. So our meeting is going to end in 4 minutes, or it's 2 by now. So I'm going to ask you to log in again so that we'll continue the rest of the session.